My name is Jim Crist. I work for Anaconda, and I'm here to talk to you about a project called Skein. So just quick a poll of the audience here. How many people use Hadoop sometimes? Okay. How many people use Hadoop on a local cluster, something you might have installed in your enterprise? And how many people use it on some kind of cloud deployment like EMR? Okay, wonderful. So I'm here to talk about Skein. It's a deploy Python on your Hadoop cluster easily. So first, let's define some terms. Hadoop clusters. Hadoop is kind of an overloaded term. If you look at the Hadoop project, the actual Hadoop repo, it's full of things like MapReduce. There's YARN, the resource manager. There's HDFS, and then there's like ancillary projects that you might also install in your cluster. So in this case, we're going to say a Hadoop cluster is a cluster of nodes managed by Apache YARN. It has many different forms. You might have an enterprise distribution like Cloudera, Hortonworks, MapR, et cetera, or you might be using some form of cloud deployment like EMR or Google Dataproc, or maybe you have a custom installation. All of these are, at their core, running Apache YARN to manage jobs. Apache YARN is yet another resource negotiator. That's what it stands for. It's the process that's there to manage the CPU and memory across your cluster. So you might have a bunch of different nodes. You might say, I want to run a process with 4 gigs of memory and 2 cores, and Apache YARN is the process that figures out where it should run that job and make sure that you're not saturating the entire cluster. And it also ensures resources are being shared across teams evenly. So if you have some team, you want to make sure that you're not monopolizing the cluster and data engineering can't get their work done. Apache YARN is a common deployment environment for lots of different data science and engineering tools. Spark, Flink, Hadoop, Hive, Impala, et cetera, all are able to deploy on a YARN cluster. So for my day job at Anaconda, I work on a similar tool called Dask. Quick show of hands, how many people have used or heard of Dask? Okay, that's nice. So Dask is it's another data science tool for deploying Python across a cluster. Many people have asked if it would be possible to deploy Dask on YARN. More generally, it'd be nice to be able to deploy any Python application on YARN. A lot of the things that run on a Hadoop cluster are Java processes. They're blessed in some form. Maybe IT or admin has set them up in a way that they can run. But if you're running like a general Python app that you might have written, you might not be able to deploy it on your cluster. You have this hardware sitting there and you're not able to use it in that way. So too long I didn't read. It works. This took a lot of work. This was about all I did for the last 6 months or so. But at this point, we're able to do demos. So right here, I have a notebook. This is running on an edge node. And I have a little project called Dask YARN. You import a YARN cluster. These are already run just to speed things up. You create a YARN cluster object. I'll talk about what this all means later, but in short, we're saying I want each worker to have 2 cores and 4 gigs of memory. It's got a nice little wrapper here. I can scale up the cluster. Connect to it while that's doing it synchronously, and I can start doing work. And all of this is written in pure Python. And that's using the project that I'm talking about today. Here I can even open up the Dask dashboard, and you can see things compute. And just to prove that I'm not lying, here is the application we're currently looking at in the Hadoop scheduler. So it's running Dask. Can even take a look at the dashboard. So, back to the slides. How did we get here? So there are lots of issues deploying Python on YARN. One does not simply do it. A couple of things. YARN is written in Java, and it has Java-only tooling. There is no client library for any other language. Supposedly, it's backend language removed. It's got protobuf spec, but it's not specified, and it's hard to write a replica in other language. Hadoop security is complicated, especially if you're using Kerberos, which is really the only way to secure your cluster. It's so complicated that one of the main authors of Hadoop wrote this fun book that compares the Hadoop and Kerberos to all of the Cthulhu novels. Every chapter starts with things about madness and staring into the void. File distribution is a lot harder. Java-centric programmers might use jars. So you might package everything up into a jar and distribute it around. Hadoop is written in this way. It expects this kind of an ecosystem. Python doesn't work that way. We're used to be able to pip or conda install stuff. And then not all clusters are the same. YARN configuration options are numerous. Different things affect security in different ways. Testing is hard. It's hard to set up a Hadoop cluster for testing, especially if you're trying to run it on Travis. So things weren't great, but things are better now. I'm going to be talking about a couple different ecosystem of projects that we've created in the last year that should make going about this process of deploying general Python or really any language applications on YARN so you can make better use of your cluster. So first project we're going to talk about is Skein. For those that aren't knitters or crocheters, Skein is a unit of YARN. It's a small amount, just enough for you to finish your project. That's what the project Skein tries to be. We take the larger YARN library and we try to simplify it down in a way that it's more accessible for you. So this is the hello world. Looks a lot like, if you're familiar with Docker Compose or other YAML-based specs, Skein is declarative. So here we're creating an app called Hello World. We're going to deploy it in the default queue. Queues are a YARN concept trying to split up your cluster into smaller bits of resources. Your team might have a queue. So this could be easily data engineering or whatever your team is named. Skein, you declare a number of different services. Here we're creating a service called Hello. We're going to allocate 128 megabytes to it and 1 core, and we're going to have it just echo out Hello World. To actually run it, there's a CLI. We just submit the spec and it runs. So I'm going to do that right now. I have that whole file copied here locally. I'm going to save the output as app ID. Let's see. Cool. So this is running. I can check the status of it. I'm going to see it's currently running. I can go over to my Hadoop dashboard and see, oh, and it's just finished. Wonderful. I can get the logs. And there you can see the command echo hello world and it echoed out. So this was all done just as that. As a user, you don't have to write any Java. We've done all of the hard parts for you. Let's see, going back. So what happened here? This is a simplified drawing of a YARN cluster. You might have an edge node or a number of edge nodes you can SSH into. This is where, if you were, in this case when I was showing the notebook, that's where the notebook is running. The edge node is where your client would run. So first, when I submitted this application, my client asked the resource manager, which is running in a separate node, to start the application. The resource manager starts a special process called the application master. All processes or applications that run on YARN have to have an application master. This is usually a Java process. It's exclusively a Java process. There's no other library to do this. The application master then manages your app. So it would say when you want to start new containers, it would ask the resource manager to start them. The resource manager may give it a container. It may say, no, you're full, we can't give you anything else. If your application master gets a container, it can then start it up, maybe on a different node. And then it just is in charge of managing, starting up, and stopping containers until the end of the app. So Skein provides a generic application master written in Java. It reads the declarative spec that you saw before, and then it manages your application as you go. It's able to dynamically scale. So we saw before when I was showing off Dask YARN that you can scale up and down at runtime. I can, here I'm going to kill a container. And we went from 4 workers to 3. Again, you can scale up. There's the slides. All right, Skein features. So it has a declarative language independent specification. That was the YAML file you saw before. You describe how your app should look, what resources you might need, what services you might want to spin up, and Skein runs them for you. It has a CLI, which is what I use to deploy that Hello World application. It also has a native Python API that should feel hopefully intuitive. We've done a lot of work to make the commands hopefully feel, the spelling hopefully to make sense. It's written with gRPC, which is an RPC specification using protobuf, so it's easy to add other languages. Currently we only have
a native Python API, but it'd be easy enough to add one for Go or R or whatever other language you might care about deploying. It has an application master and a client provided. These are the processes that need to speak to the YARN services. These are the things that currently have to be written in Java because there's no other way to do it. We've wrapped those up as gRPC services so they can talk to Python without you having to worry about writing Java. It also has an internal key value store for coordinating applications. Say you might have some runtime configuration. Maybe a service starts up and it needs to tell what the other services its host name is. You can store that there and then they can pull that back out. And it also has an extensible web UI for tracking and interacting with applications. And I'll be showing these later. All right, a little more useful script. This is specifying how to run a Python script on a node. So instead of just echoing hello world, we're going to do a couple other things. In this case, we're adding on script.py, which is a script file. I might have something I want to run, and maybe it's a long-running script. I don't want to take up resources on the edge node. I'd like to have that run somewhere in the cluster where I can shut down and log off and go home for the day. And then command python script.py. Notice this doesn't distribute any of the extra libraries you might need. So if you have all of the resources you need in the Python distribution on every node, this would work fine, but often you don't. Maybe you need some special library that IT hasn't installed in every node in your cluster. In that case, you need to distribute the files with the application. So for Java-centric programmers that would be using YARN, usually you would distribute things with extra jars, and then YARN would move those around and get them located in the nodes so you could use them. For Python, we have a couple different libraries for doing a similar thing. One called condapack for if you're using con environments, and another called vmpack if you're using virtual environments. This is, let's see, condapack is a CLI command for packaging up a con environment into an archive file, and then YARN knows how to move around archive files and it will automatically unpackage them into a directory on all of the nodes that you're using. So as an example, let's say I want to package up, I have an environment called PyScript. I'm going to overwrite, I already have this packaged up here. So it's going to collect all the packages and it's going to create an archive file. This takes a couple seconds. Wonderful. So here we have so it's about 150 megs. So it's a rather large thing. If you're using virtual VMs, these are smaller. But this is a way that you could have an exact replica of your con environment on every node. I'm going to skip ahead real quick. Note this also works with PySpark. So this isn't specific to Skein or anything. This is just a general YARN feature. In our docs, we have docs on all of the weird incantations you need to actually make things work with PySpark or sparklyr. There's a lot of different environment variables you need to set, but this is a way you can use con environments with Spark as well. Going back one bit, I have an example right here that actually, for the sake of time, I'm not going to run this. I'm just going to talk this one through. Here we'd have an example Python script. We ship along the environment packaged up as a tar file. The mapping here says to Skein on the other side, on every node, I want to unzip or untar this archive file into a folder called environment. And then in my actual list of commands, I'm going to source that environment, and then I can run my script. And this is going to run inside the same con environment that I would have locally, but on a node. I can also set environment variables here. For those, if you use Arrow, which is a great library for reading various different data sources and converting between them, sometimes you have to specify where the HDFS client lives. So in this case, that's what I'm telling it with this environment variable. Let's see. Moving on, additional features. So I mentioned before we have a key value store. So instead of using something like Zookeeper or other things that might be already running on your cluster, all Skein applications come with a key value store bundled inside the application master, the process that has to start before any other containers start. This is nice because you can have a consistent environment. You always know that you have this key value store available. It's only accessible for containers within that application, and you can store whatever dynamic configuration you need there. It's inspired by etcd, which is the key value store used by Kubernetes. We can mimic a lot of its operations, atomic transactions, key and range operations. You can subscribe to keys. I can say I want to watch every key that starts with dask. And as keys come and go, I'll get notifications as they're set or deleted. And it has an ownership model too. Using these various different operations, you can build larger concurrency abstractions. You can build distributed queues, locks, various things on top of it. This was actually kind of fun to write just because from a simple set of primitives, you can build complicated concurrency abstractions. I have another application running right now. I'm going to demonstrate this with. So this is currently running. I can set a key. We'll say foo, and we'll set its value to var. And then I can get that key. And so this is a way, dask YARN, which I showed before, the scheduler starts up first, and then it stores its address in the key value store, and then when all the workers start up, they can pull that address from the key value store. This has proved useful for other applications too. One user is using a distributed queue to manage the level of work throughout the whole cluster and storing all of their information in the key value store. Let's see. It also has an extensible web UI. So YARN supports application web UIs. If you're deploying Spark, you've probably seen the web UI. If you click on the resource manager, you can go through and see what Spark's doing. Due to reasons, it only supports Git operations. You can't use any modern web features like WebSockets, but you can still build some useful dashboards. Going back to that same dashboard application I currently have running, that is here. Let's pull that up. So this is the Skein dashboard. On this application, I have two services, one called Dashboard and one called Sleeper. It's got a number of different containers running. If some of these were to die or shut down, they'd be in the completed section. I can take a look at the logs for different services and runtime. And then I mentioned that it's extensible. Applications can register additional pages. Here, this one is running a bokeh app, which is being proxied out through. This can't use modern features like WebSockets due to limitations in YARN, so this is having to poll every couple seconds to update new information. But this is all, again, written in pure Python. I didn't have to write any Java to do this. The actual code for this app is like maybe 100 lines. Yeah. All right, so we went through deploying on YARN. We went through packaging up dependencies. One of the other issues we mentioned was testing. So testing YARN applications is rather tricky. The YARN docs themselves say if you don't test your YARN applications in a secure Hadoop cluster, it won't work. There's a lot of different things you need to make sure you do. You need to make sure you get delegation tokens and make sure security works with Kerberos, and it's just a whole handful of stuff. Cluster deployment is also insider knowledge. It seems a lot of the configuration options for YARN are not well documented. Knowing what is set in an enterprise, what Cloudera might set up or what Hortonworks might actually set up is the secret sauce. And it's not trivial to set one up on CI. Luckily, we have a tool called Hadoop Test Cluster for doing this for you. So this is a CLI tool for spinning up realistic test clusters. These look like production clusters. It matches what Cloudera would do. It supports all the different kinds of authentication that Hadoop supports, runs fine locally or on Travis. We're using this for a couple different projects to test Hadoop integration on different Python projects. And it's designed to be extensible. It is pip installable. Just pip install Hadoop test cluster and then create a cluster and log in. I'll demonstrate that right now. I'll start. You can also mount local directories. So for testing, I might mount the local Skein directory and then log in. And just to prove it, oh, interesting. Well, that's a fun thing. Oh, I didn't type it right. Cool. So it creates, there's a bunch of different accounts already on here. For Kerberos things, we create a key tab. We create a bunch of different things you might want to use for automated testing. Let's see. So putting it all back together, all of these projects combined have allowed us to write Dask YARN, which I showed in the beginning and I'll talk a little bit more about now. So Dask YARN uses Skein to manage all of its YARN things. So the actual Dask YARN library is maybe 150 lines of Python, just wrapping, there's a Skein specification, and then making some nice methods. It's installable like any other Python library. To use it on your cluster, you just pip or conda install it onto your edge node and you can get going. It doesn't require any admin or IT permissions besides SSH access to the edge node. If you have access to that edge node, you can run Dask on your cluster today. You can create clusters programmatically, as we did here, where we created an object and this manages the lifetime of your cluster. Or you can use, there's a CLI, mirroring Spark Submit. You can submit applications to run in the background on your cluster while you go home and let it run overnight. Yeah, we already showed that there. Ongoing and future work. So one person from Criteo, which is an ad company out in France, is using Skein to deploy TensorFlow on YARN. They have a project called TF YARN for running distributed TensorFlow on a YARN cluster. Ray is another distributed Python project. They're looking at using Skein to deploy Ray on YARN. There is a project called Jupyter Enterprise Gateway. This is a tool for, instead of having Jupyter Hub, which might run all of your kernels locally, this is a tool for spinning out all of the kernels to run on any kind of cluster. Maybe you have a Kubernetes cluster and you want to run different Jupyter kernels on every node. In this case, it would be nice to use Skein to deploy kernels on YARN, and then also be able to deploy Dask through Jupyter Hub as well in a nice way. And then there's more work we want to do for Dask YARN, adaptive scheduling, and then we'd like to rewrite the dashboard to work in the restrictions of the YARN proxy, which doesn't support modern web features. Currently, the Dask dashboard uses WebSockets. So in review, we have a couple different projects that we talked about. Skein is a tool for scheduling and managing YARN applications from pure Python. You don't have to write any of the Java, it's already done. CondaPack and VMFAC are tools for packaging Python environments for redistribution. Works well with anything that deploys on YARN. It also is useful generally. Hadoop Test Cluster is a tool for nicely spinning up a test cluster for testing on a realistic Hadoop installation. And then Dask YARN uses all of these together to run Dask on YARN clusters. If this sounds useful to you, I would love to talk to you. You can get in contact via Twitter or GitHub, or I'll be here the rest of the conference. And I believe we have time for questions.
Way up here. Can you talk about using CondaPack outside the Hadoop environment? Is that possible, or am I going down the wrong road there?
So the question is, can you use CondaPack outside of Hadoop? Yeah, plenty of people do that. CondaPack is designed to, you have a Conda environment, it packages it up, you can move it somewhere else, unpackage it, and then there's a small little command to fix up anything that didn't unpackage properly the first time. Going a little more in depth on what that means is many packages, especially if you have a CLI command, some kind of entry point, embed absolute paths into them. So the simplest example would be a shebang at a script file. CondaPack rewrites those to work generally, but for ones that can't be, absolute paths that might matter beyond things that can be turned into relative paths, we write another tiny script called conda unpack. And so the full workflow would be untar your archive, run conda unpack, and it's exactly as if conda had installed everything there originally. So this is nice for deployment scenarios where you have an application, you bundle it all up, and then you can deploy it just by untarring. Most things, though, work without running the fix-up script. Anyone else?
Anyone else?
Cool. Oh.
Is it possible to put all the dependencies in a single
I'm sorry, I didn't hear that.
Okay, let me, wait a moment. Sorry. Hello?
Hi. Is it possible that we could package all the dependencies, like how jar does from Maven and builds it like a individual thing for Python using conda pack, like instead of taking the zip, untarring it and all that? Like,
That's exactly what Conda Pack does, is it archives your entire Conda environment in a way that it can be reused and activated on a node.
with the scripts also that we develop for the modules and all that?
Yeah.
Okay. Thank you.
Anyone else? All right. Well, if you would like to talk to me afterwards about any of these projects or just about Dask in general, I'll be around. Thank you.